Section 3.3, number 34. Here we are given two graphs of two functions. Y is equal to this quadratic x squared plus 2x minus 1 over x plus 3, or divided by x plus 3, if you will. And the second one is y2 is equal to x minus 1 plus 2 over x plus 3. We are told to, number one, graph them and determine that they are equivalent. You all have graphing calculators. I trust that you can do that. And the other way is to show algebraically that they are equivalent. Now there's two ways of doing this. Probably the most straightforward way is to take this property, this thing x minus 1, treat it as a single chunk, and then multiply top and bottom by x plus 3 and stick them all together. But since this section I'm trying to hammer home and show practice on long division, I'm going to do it that way. I'm going to do long division on this one and show that I get this expression out in the end by showing that when I do the division, this x minus 1 is going to be on top of my division symbol, and this 2 is going to be my remainder. Okay? So let's do that. So we're going to get x plus 3 dividing the expression x squared plus 2x minus 1. All right. And so our process is always the same here. What do I need to do to my leading term in the thing that I'm dividing by to get the leading term on what's left underneath our divider? Okay? Well, to get x into x squared, I need to multiply by an x. So x times x is x squared. X times 3 is 3x. Now I subtract this, but subtracting is the same as flipping the signs and adding. So adding down the square column, x squared minus x squared is 0, so that term goes away. 2x minus 3x, well, that becomes a minus x. All right, now I bring down the piece that I have left over there. And what do I need to do to the x to make it look like a minus x? Well, I have a positive 1 here. Right, remember, there's always these 1s in front. So I need to multiply by a negative 1 to make the x look like a minus x. Negative 1 times x is minus x. Negative 1 times 3 is minus 3. Now I need to subtract this to get rid of my minus x, but subtracting is the same as flipping the signs and adding. Minus x plus x is 0. That term goes away. Minus 1 plus 3 has 2 as a remainder. So doing this division, I get that my y1 has to be x minus 1, right? Because that's what I get out of doing the division, plus my remainder 2 over this x plus 3. Okay. So this is simply me restating the y1. Is it identical to the y2? Well, it is x minus 1 plus 2 over x plus 3. So they are identical. Again, if you want to see them graphed together, you graph this, you graph that, and they should be the same.